Okay, so we are learning substitution this time. We're solving our system of equations by substitution. Think of substitution in the real world. You can substitute ingredients in recipes, okay? You can have a substitute teacher. Is your teacher still here when you have a substitute? No, it's replaced. Same thing with ingredients. Hey. Okay, same thing with ingredients. If we are going to substitute something, we don't use the original ingredient. We replace it with something different. Okay, so the first thing you're going to want to do is pick a letter, X or Y, whose coefficient is 1. You preferably want it to already be by itself, but there are no letters already that by themselves, so we don't have that option. What I mean is something like this. You see how the Y is already by itself in one equation? That's what we need to create, is something where we have one in standard form and one that has a letter by itself. So I always look for which one has a coefficient of positive 1. You could do negative 1, but positive 1 is easier. So looking at both of these equations and all of the letters, which one has a positive 1 coefficient? The X in the top equation. Y'all are exactly right. So I need to get that by itself. So I have X minus Y equals negative 7. How do I get this X alone? So now I have X equals negative 7 plus Y. So this is my substitute. So I always circle my letter, and what it equals is your substitute. Because if they're equal, they're the same. So my next step says to substitute it into the other equation. So the equation we have not used, which is 2x minus y, equals negative 9, is the equation that we're substituting it into. So if we know x equals this, I know that I can replace x with this. Because if they're equal, they're the same. So I have 2 times negative 7 plus y minus y equals negative 9. So now I solve. First things first, we need to distribute and simplify the left side. So 2 times negative 7 is negative 14, bless you. 2 times positive y is positive 2y. Bring down this negative y equals negative 9. Yeah, I'm going to combine my like terms. So I have 2y minus y is the same thing as saying minus 1. So 2 minus 1 is 1. This gives me a positive 1y, or just positive y, either way. And I'm going to bring down that negative 14 equals negative 9. Now, how do I get my y by itself? Yeah, I'm going to add 14 to both sides. And I get y equals 5. So that is this step. Now, that's only half my answer, because I know for systems, my answer is an x comma y point, ordered pair. So I know that y is 5, so I know the second number is 5. I still have to find x. So to find x, I'm going to go back to the original substitution equation. Not the original, sorry, but the substitute equation, which is this one. X equals negative 7 plus y. I know it says original, but we're just going to use the original substitute. And we know that y equals 5, so I can replace y with 5. So x equals negative 7 plus 5. What's negative 7 plus 5? There is my answer. And if I asked you what kind of system, you would tell me independent and consistent. Now, we can check our work with these, and it's super easy in the calculator. So we know our answer is negative 2, 5. And I'm going to come up here and look at my original equations. So I know that x is negative 2 minus y is 5, and that should equal negative 7, and it did. Okay, and then I know, again, 2 times negative 2 minus 5 is negative 9, and that also worked. So that was the correct answer. Any questions with that one? Okay, so let's look at example 2. Okay, so if we look at example 2, thank you, which letter do we want to get by itself? Which letter has a coefficient of positive 1?
The bottom
one. The second one, the y. So we're going to get that y by itself. How do I get that y by itself? And that moves away. So I have y equals negative 3 minus 2x. And that is my substitute. So then remember, we take the other equation that we did not mess with. So negative x minus y equals 3. And because y equals this, I can replace y with it. So I get negative x minus, and instead of y, I'm going to plug this in. And now I'm going to solve. What do I need to do first? Distribute what? The negative. So that negative x stays. I'm only distributing this negative touching my parentheses. 2 negatives makes a positive. 2 negatives makes a positive. So all it did was change both of those negatives to a positive. Now what? Yeah, what's negative x plus 2x? X. Bring down my plus 3 equals 3. Now what? Subtract 3 on both sides. And I get x equals 0. That's okay because 0 is a number. So I know that my point for my solution, x is 0, but I still need to find y. So that's where my substitution problem comes in. And I know that x equals 0. So I'm going to replace x with 0. So I get y equals negative 3 minus 2 times 0. What's anything times 0? So that cancels, and I get y equals negative 3. Okay, number 3 is a special case. And I'll show you why here in just a second. So if we look at it again, this one's already set up. We already have our substitute ready. Okay, and I'm going to replace this y with this. So I get 2x minus 3, and instead of y, I'm plugging this in. 2/3 x minus 6 equals negative 15. And first things first, just like the other ones, I have to distribute. So negative 3. So I'm going to bring down my 2x. Negative 3 times 2/3 x. If you type that in your calculator, it gives you negative 2x. Negative 3 times negative 6 is positive 18 equals negative 15. Now what do I do? Combine my like terms. What's 2x minus 2x? They cancel. And so I'm left with 18 equals negative 15. Can I even solve this anymore? No, I don't have any letters. My letters canceled. So does 18 equal negative 15? No, so this is false. So what do you think your answer is? No solution. Bless you. Now, what if we got 12 equals 12? What would your answer then be? Infinitely many solutions. So it's true. So you get IMS, infinitely many solutions. Okay, flip to the back. So we have 2 word problems. Okay, so always read them all the way through first. So it says City Park Golf Course charges $20 to rent golf clubs plus $55 per hour for golf cart rental. Sea Vista Golf Course charges $35 to rent clubs plus $45 per hour to rent a cart. What number of hours is the cost of renting clubs and a cart the same for each course? Okay, so starting, we have the City Park Golf Course, and they charge $20 plus $55 per hour. So X, that tells me to put a variable. I also, because it says per hour, I know x represents the number of hours. What do you think I put next in this equation? Do we know our total cost? So we have equals y because we don't know the total. Y represents your total cost. So then we have C Vista Golf Course that charges $35 plus $45 per hour for your cart. And again, we don't know the total. So this one's set up a little different. They both could be substitutes, but how many substitutes do we need? One. So I'm just going to pick the first one. This is my substitute. So I'm going to replace this y with what's in parentheses, and I get 35 plus 45x equals 20 plus 55x. What do I do? Yeah, I always move my smallest variable first. Technically, you can move anything, but this just keeps it organized. And I get 35 equals 20 plus, that gives me 10x. Now what? Minus 20 on both sides. And that gives me 15 equals 10x. Last step. Divide both sides by 10. And I get x equals 1.5. Now, before we even plug it in to find y, read the question. It says, for what number of hours is the cost of renting clubs? Well, it says for what number of hours. Does it say what's the total cost? So all we need is hours, and what represents hours, x or y? And what does it equal? So in 1.5 hours, or how else could you word that? 1 hour and 30 minutes. I would take either of those, just so you know. Now, what if it asked for our total cost? What would we do? Plug it in. We just put it to either equation because they should be the same if we solve correctly. Okay. Okay, last one together. Look at number 5. It says the math club raised money for its summer trip by washing cars. They charge $3 for a car, $5 for a truck. Suppose the club earned a total of $181 for washing a total of 49 vehicles. Write a system of equations stating these facts and solve the equation to find out how many of each kind of vehicle they wanted. So our two unknowns are how many of each vehicle. What two different vehicles did it say? Cars and... So I like to pick my own variables. And I'm going to write UC for the number of cars and T for the number of trucks. This step is super important, defining your variables, because if not, you get down to x equals 1.5 and you don't know if x represented total cost or hours. Okay, so we're going to go back and read. It says they charge $3 for a car, so $3 per car plus $5 per truck. And they earned a total of $181 for washing a total of 49 vehicles. Well, which total do you think goes here? 181 or 49? No, it's actually 181 because money goes with money goes with money. All three of those numbers had dollar signs. So if we're talking about cost, we need to talk about cost all the way through. Does that make sense? Okay. Now, the second total says a total of 49 vehicles. So we know it's going to equal 49. Well, what represents the number of cars and the number of trucks? Yeah, C plus T. So there's our equations. And we know that we're obviously going to use that second equation for our substitute. So it doesn't matter because in the end we have to find both cars, so it doesn't matter what we solve for here. So I'm just going to do minus t, and I get c equals 49 minus t. Well, here's my substitute. And I'm going to take the original equation, so 3c plus 5t equals 181, or the other equation, sorry. and I'm replacing C with 49 minus T. So what do I do now? Distribute. What's 3 times 49? And 3 times negative t is negative 3t. Bring down my plus 5t equals 181. Now what? And what's negative 3t plus 5t? Now what? And that gives me 34. Last step. And I get t equals 17. Am I done? No, because I also need to find c. But I'm going to use my substitute equation, which is c equals 49 minus t. And I have c equals 49 minus t. And I know that t equals 17. So I'm going to replace t with 17. And I get 49 minus 17 equals 32. So what's my final answer? $32 cars and 17 trucks. Perfect. Now again, you could check your work. You can plug those in for C and T in your equations, and it should be equal for both of them. The only thing I need to tell you about your practice is if you look at the back of the practice, number 7 and 8 say do not solve. All you're doing is setting them up. Yes? Now number 9 and 10, you're setting up and solving. Okay?